Chapter 3, Section 8, Bias in Data. In this section, you will learn what types of bias can occur in data collection and how they are different. For example, what are differences between selection bias and sampling bias, and between observer bias and confirmation bias. You will also learn how to mitigate these biases in data collection. Bias in data refers to systematic errors or prejudices in data that inaccurately or unfairly represent a particular group or phenomenon. Bias can occur at the various stages of data collection process. In machine learning, biased data can lead to models that perform poorly for certain groups or discriminatory conclusions, which can have ethical and social implications as well as poor prediction. These are common biases that can occur in data collection. This is not an exhaustive list, but all of these should be considered in data collection. Let's go through them one by one. The first is selection bias. Selection bias is a problem caused by systematic errors in the way samples are selected or included, and how samples are selected in a non-random way. Selection bias is a problem where the sample does not represent a population due to errors in the way the sample is selected. In the case of surveys of people, selection bias often occurs when the people selected for the sample have different characteristics from those who are not selected. For example, in a study of exercise habits, if only people who want to participate in the fitness program are surveyed, selection bias may occur. This is because the people who want to participate may already be more motivated or interested in fitness than the general population. Random sampling is the fundamental method to mitigate selection bias. Simple random sampling is a method that gives all individuals in the population an equal chance of being selected as a sample. This is the most basic method for reducing selection bias. Stratified sampling is slightly more complex. In this method, the population is divided into subgroups based on the important characteristics of the population, and a random sample is taken from each subgroup. For example, if the population's age distribution is such that half of the people are in their 20s and the other half are in their 30s, then the sample is taken from the 20s and 30s groups in equal numbers. It makes the sample more representative of the population. In experimental methods, using a control group is also effective. When we want to investigate the effect of an intervention, in addition to the treatment group that has undergone the intervention, we can prepare a control group that has not undergone the intervention. This makes it possible to clearly verify the impact of the presence or absence of the intervention on the results. The second is sampling bias. Sampling bias occurs when the sample used in the study does not represent the population. This is usually due to how the sample is chosen, and can occur when certain groups are over or underrepresented. For example, imagine we go to a shopping mall on a weekday during the day to conduct a survey. In this case, people working or attending school will likely not be at the mall. So, only a specific group of people, such as housewives and retired persons, will participate in the survey. As a result, the opinions of company employees and students will not be included. So, a biased sample will be obtained that does not reflect the entire population's opinions. This is an example of sampling bias. Sampling bias and selection bias are similar, but they are different. Selection bias occurs when the participants in a survey are biased toward certain criteria or conditions. Sampling bias is a problem where, even if you think you have chosen randomly in a specific way, the means of data collections are regionally biased, or survey was conducted at a particular time, which causes bias in the sampling obtained. Next, let's look at ways to reduce sampling bias. The most basic way to prevent sampling bias is to increase the sample size. By increasing the sample size, you can capture a more diverse or representative subset of the population, and reduce the possibility that the sample will be biased towards a particular group. In addition, as with the case of selection bias, using random sampling can reduce bias in the sample. There are various methods including simple random sampling, stratified random sampling, and systematic random sampling. The third method is to design an appropriate sampling frame. Specifically, this means designing the sampling so that it includes important segments of the population. This prevents specific groups from being excluded from the data. For example, in the case of an online survey using a mobile app, you should check whether it is a problem that the respondents are limited to users of mobile tools, and if necessary, consider collecting data using other tools. Another bias, measurement bias, occurs when the measurement method used to collect data causes the value to be recorded in a biased way. When this bias occurs, the measured data no longer reflects the true value, and it may distort the results of the analysis. If the equipment or tools used for a measurement are inaccurate, measurement bias will occur. For example, if a scale is broken and always displays 1 kilogram or less than the actual weight, the weight data will be biased. In addition, measurement bias will occur if the way questions are asked or the order of question in a questionnaire or interview promotes particular types of responses. As to measurement bias, we need to pay close attention to the design and implementation of the measurement tool. The first one is doing a pilot test of the measurement tool. Measurement tools include survey and interview protocols, electronic instruments, etc. Implementing a pilot test of the measurement tool before the main survey can help identify potential sources of bias in the data collection method and interpretation of questions. By conducting a small-scale pilot survey, we can get feedback on how respondents understand and respond to questions, or how measurements are recorded. We can use this feedback to fine-tune the measurement tool. The second is to use standardized tools. In the case of questionnaires, it is effective to use questions that have already been verified for reliability and validity for measuring specific variables. This increases the likelihood that the target variables will be measured correctly. In addition, using standardized tools consistently will bring consistency to data collection, making it possible to compare data. The third is training of data collectors. By providing thorough training to all data collectors on how to conduct surveys, record observation results, or use measurement devices consistently, you can prevent bias from entering the data. For example, in the case of interview survey, we need to train interviewers not to use leading questions and utterances that may influence the respondents' answers. Both observer bias and confirmation bias are types of cognitive bias that affect how people perceive, interpret, and record information. Observer bias occurs when observers' expectations, beliefs, or preferences consciously or unconsciously affect how they observe, interpret, or record. For example, let's imagine a case where a researcher is investigating several schools. Let's say that this researcher believes that the students at a particular school are excellent. This expectation could lead to the researchers constantly interpreting and measuring the statements and actions of the students at the school in a positive light. To reduce observer bias, minimizing the subjective influence in the data collection process is necessary. The first method is masking. This is a method of reducing bias by not informing the observer of important information that may affect the observer's observations. For example, in a single masked design, the observer observes each participant without knowing whether they are in the intervention group or the control groups. In a double masked design, both the observer and the participant are masked, so neither the observer nor the participant knows which group each participant is in. The second is a clear definition of what is to be observed. By clearly defining the variables and behaviors that the observer should observe, it is possible to reduce bias due to subjective or inherent interpretations by the observer. This method involves defining the behaviors and outcomes to be measured in a way that leaves little room for subjective interpretation. For example, when observing a meeting, instead of asking observers to judge whether participants are involved, you can present specific behaviors that indicate involvement, such as asking questions or expressing opinions. The third step is to prepare a standardized observation protocol. Using a standardized protocol, we can ensure that observations are implemented uniformly, and thus reduce the possibility that the observer's subjective judgment or preferences affect the results. For example, we can provide observers with detailed instructions on how to collect the data, what to observe, and how to record it, as well as the structured observation form with standardized questions. Confirmation bias refers to the tendency of an individual to seek out, interpret, and remember information that confirms their existing beliefs or hypotheses. This can lead to the ignoring of evidence to the contrary. This bias occurs because people naturally tend to focus on information that supports their point of view and ignore information that contradicts it. For example, if a researcher believes that a particular intervention will be effective, he may reinforce his belief by focusing on positive results and ignoring negative or neutral data. Although observer bias and confirmation bias are similar, they are not exactly the same. Confirmation bias can occur in contexts other than direct observation, affecting how we seek and interpret the information when reading newspapers or talking with our colleagues. There are several ways to reduce confirmation bias. The first is to use a null hypothesis. By testing the null hypothesis, the researcher is forced to consider evidence that may contradict their hypothesis, and this reduces confirmation bias. In other words, rather than supporting the original theory, the researcher carries out an analysis that rejects the null hypothesis. This shifts the focus from providing the endorsement for one's own views to critically evaluating whether there is sufficient evidence to reject a null hypothesis. The second is to use a double-masked method. By collecting data in a way that neither the researcher nor the participants know which group each participant belongs to, the researcher will become less likely to interpret the data in a way that suits her expectations. Third, a variety of data sources and methods should be used. By using multiple data sources and methods to verify results, we can reduce confirmation bias by ensuring that conclusions are not drawn from only one type of evidence. For example, using both interviews and questionnaires can provide a more comprehensive picture of the phenomenon being studied. Social desirability bias is a bias that occurs when respondents are aware of how their answers or actions will be evaluated by others when taking part in surveys or data collection. So, they tend to answer in a socially desirable way rather than their actual opinions or actions. Because respondents are concerned about how they will be evaluated by others and about social expectations, they will skew their answers in a more socially acceptable way to be seen more favorably or avoid being criticized. In particular, questions that involve ethics, morality, or fashions that relate to values or behaviors widely admired or strongly condemned by society are likely to be distorted by social desirability bias in questionnaires and interviews. For example, when asked, "Do you ever discriminate against people based on their race or gender?" Even if the respondent does have prejudices or discriminatory behavior, it is common for them to answer no. The respondent chooses the socially desirable answer in order to avoid being seen as discriminatory. In order to effectively reduce social desirability bias, it is important to apply strategies that encourage honest responses and relieve their pressure to conform to socially acceptable responses. The first is to anonymize responses. If respondents know that their identities will not be revealed, they are more likely to answer honestly, without fear of judgment, and this can reduce the social desirability bias. Specifically, anonymity is ensured by not collecting information that could identify individuals and using an encrypted questionnaire platform to prevent data leaks and unauthorized access. However, it is important to note that even anonymous responses cannot eliminate the social desirability bias. The second method is to use indirect questions. For example, rather than asking respondents directly about their behavior or attitudes, the questions are phrased to ask respondents to respond about the behavior or thoughts of others. For example, instead of asking, "Have you ever cheated in an exam?" you could ask, "How common do you think cheating in exams is among students?" Another way is to ask for opinions on a short story or short video rather than a questionnaire, so that respondents can answer without being conscious of the social desirability. The third is to gather information about actions and results rather than intentions. If you ask a company's recruitment staff whether they think it is important to recruit without discrimination based on gender or race, and ask them to respond with a yes or no, they will likely respond in a way that conforms to social norms. Even if you want to know what individuals think, it isn't easy to find it out through a questionnaire. Therefore, although the purpose of the question is different, it would be more useful to ask about the actual number of people hired and the hiring rate by gender and race. During data collection, various biases can easily creep in, and as a result, the data obtained might contain bias. In this section, we have covered selection bias, sampling bias, measurement bias, observer bias, confirmation bias, and social desirability bias. We also discuss ways to mitigate these biases, such as random sampling, standardizing, measurement tools, and using various measurement methods. Since machine learning analytics often require large amounts of data, completely eliminating these biases can be quite costly. However, it is important to design data collection methods that can eliminate as many biases as possible. It is also important to be aware of various types of biases to analyze and interpret data while considering the possibility of bias being present. Thank you for watching. Please thumbs up and subscribe to my channel.